Okay, so the next one. Okay, so in many practical cases, okay, so we only want to find either an absolute maximum or an absolute minimum in a given region R, which is open and bounded. Okay, so furthermore, the region may not be closed or bounded. Okay, and hence we cannot use the previous theorem. Okay, so we need in the case of open and unbounded region, we need to use this following theorem. Okay, so if fxy assume only a local maximum and there is no local minimum and no saddle point in the region, okay, then the local maximum is the absolute maximum in the region. Okay, second, if the fxy assume only a local minimum, okay, meaning that there is no local maximum and saddle point in the region, then the local minimum is the absolute minimum in the region. Okay, if we have the local maximum within the region, we can consider the local maximum as absolute maximum. Okay, and if the region only have local minimum, therefore we can say that that one is absolute minimum. Okay, considering there are no other local minimum or maximum point and no saddle point. Okay, alright, so for this case we'll use the same method as we find in the local extrema. Okay, first we need to find the critical points and then we need to equate the fx and fy equal to 0, and then we need to find the critical point A and B. Okay, alright, and then we need to compute the fxx, fxy and fyy. Okay, and then we need to compute the g, okay, the value of g, gab. Alright, and then we need to check, okay, the point if the gab is greater than 0, or if the gab is less than 0, or if the gab is equal to 0. Okay, then we can conclude the point, whether the point is local maximum, local minimum, or saddle point. Okay, alright, and then we can check, and then we can conclude, alright, whether that one is absolute maximum or absolute minimum in the region. Okay, now let's look at the example here. Okay, find the absolute extremum, okay, of the fxy, okay, is given here, where the region is 0 until infinity for x and for y is 0 until infinity. So we know that this case, since it is 0 to infinity, okay, so we know that it's classified as open and unbounded region because it's until infinity. So we will use this theorem to solve that problem. Okay, for this example 2.